Hello, boys and girls. This is Mr. Giomini. Wanted to give you a couple examples from your Chapter 3 pretest that were missed by quite a few of us as a whole. So we'll focus on those, give you a little bit of modeling for those, and that way you might have some resources to use as you prepare for your post-test. Let's take a look at, I'm going to skip number 12 and go to 13. 13 is a little bit more challenging. And again, I think one of the problems is we're really not doing a great job of reading things, boys and girls. I think we're kind of just breezing through things. So if I look at this, it's w minus x minus y for w equals negative 23, x equals 23, and y equals negative 23. Now again, if I'm solving this on a piece of paper, I might first say, hey, this is my work for number 13, Mr. Giomini. And I might again write w minus x minus y. Scroll this up, and then I know that, let's see, w equals negative 23, minus x is 23, and then we have minus y is negative 23. Okay, so I'm going to write this down here so I can tear it apart a little bit more. So I have negative 23 minus 23 minus negative 23. Okay, a couple things I could do with this, but I'm just going to solve it from left to right. All we really have is subtraction here, which really we subtract, we're adding as well with these integers. I see subtracting integers, so I remember this whole little saying that is new to some of you. You can, KFC chicken. Well, how about we try KCC? Keep the first one, we're subtracting integers, so keep the first one as negative 23. Change this operation sign to plus, and then change this second integer to the opposite of what it is now. So it's the opposite of 23 is negative 23. So this makes it a little nicer for me because I have negative 23 plus negative 23. Well, negative plus a negative, signs are same, so let's just get the sum. 23 plus 23 gives me 46. So I have negative 46. Now I have that minus negative 23. And again, when I am subtracting integers, I can kind of think of KFC, Kentucky Fried Chicken, or KCC. Keep, change, change. So this negative 46 stays a negative 46. Change this to its opposite, which is a plus, and change this to its opposite. The opposite of negative 23 is 23. Now when I add integers, signs are different, find the difference. So difference means to subtract. So I know in my head that 46 minus 23 in the ones place. 6 minus 3 is 3. 4 minus 2 is 2. And again, if I want to double check this, I can just write over here, 46 minus 23 equals 23. And now I look at the two numbers, negative 46 and 23. Which one has the greater absolute value? It would be negative 46. My answer is negative. I spent $46. My buddy just gave me $23. Or let's say I borrowed $46. Try that. I owe somebody $46. I just paid him 23. I still owe them 23. Owing is a negative. So this answer would be negative 23. Let's take a look down here. I think these will be pretty well, I think you have to handle these pretty well in this post-test. Just to get some examples here, let's go with 168 divided by negative 12 divided by 2. A positive divided by a negative will give me a negative. So 168 divided by 12. I can't do that in my head. 168 divided by 12. That's 1. That becomes 12. I subtract. That is 4. Bring down the 8. 12 goes into 48, I think, 4 times. So that gives me 14. So I have 14. And that is a negative 14, if we recall, because it's a positive divided by a negative. Negative 14 divided by 2 equals negative 7. Okay. If I take a look at another problem, let's go with this one here. Negative 240 divided by 15 divided by negative 4. So I'm going to go from left to right. All we have is division here. Let me erase some of this stuff to kind of give me some more space. All right. And again, if you're doing this on your post test, you just number the problem that you're doing and show the work for that. Organize it nice and neatly. So I have number 17 here. I have negative 240. I'm going to put divided by this. Divided by 15. Well, that goes in once, so that is 15. I subtract, I'm left with 9. Bring down the next digit, which is 0. Well, I know 15 goes into 30 twice, so that means 15 goes into 64 times, and I think 15 goes into 96 times. So that would give me 16. But if you recall, it's a negative divided by a positive, so that'll give me a negative. So now I'm left with negative 16 divided by a negative 4. Negative divided by negative gives me a positive. 16 divided by 4 gives me 4. Hopefully those three are some nice examples for you. Let's take a look at some other ones that were missed quite a bit. This graph, each set of integers on a number line, well, let's take a look. Negative 7/10. Well, that's easy. That goes right here. Negative 9/10. So that's easy. That goes right here. Negative 1 1/10. That's not a problem. That goes right here. Uh-oh. We have a problem, Houston. I have no idea what 1/12 is as a decimal. I know we have 1 and 1/12, but I don't know what 1/12 is as a decimal. So I'm going to write the fraction here, 1/12. How do I convert any fraction into a decimal? This really says 1 out of 12 or 1 divided by 12. 1 goes in the house, 12 gets kicked out of the house. I will put a decimal here, add a decimal in my quotient, slap on a couple zeros at the end here. 12 goes into 1 0 times. 12 goes into 10 0 times, doesn't it? Am I right so far? 12 goes into 100, I think, roughly, is it 8 times? Let's try 8. 8 times 12, I think, is 96. Subtract, that's 4. Bring down a 0. 4 goes into 40, I think, 3 times. Right? That's 36. Subtract, that's 4. Bring down a 0. Looks like it's a repeating decimal, so this is 1 and 83 tenths, hundredths, thousandths. 183 thousandths, and it's a negative 1 and 83 thousandths. Let me just double check my math again, because for some reason, I don't know. Maybe that just doesn't seem right to me. So I know the negative 1's right. Then I go 1, numerator goes in, denominator goes out, divided by 12, put the decimal, add some zeros. Again, I always like to check my work, boys and girls. It's okay to check. Doesn't mean, that's not a sign of lack of intelligence. That's showing intelligence. 12 doesn't go into 10. 12 goes into 100. Did I say 8 times? 8 times 2 is 16. There's 1. 8 times 1 is 8 plus 1 is 9. 96. Subtract, that's 4. Bring down the 0. That gives me 3. That's 36. It looks like this is just going to repeat. So it's a rational number because it repeats. Now, where am I going to put this on a number line? If this is 1 and 1/10, this is probably 1. So I'm guessing negative 1 and 83 thousandths is a little smaller than negative 1. So would I go, let's see here. I'm thinking right about real close to that negative 1 there. Okay. Let me erase some of this stuff. If you see anything wrong, please feel free to email me. It's late for me. It's already almost 4:30. So let's take a look at some things here. Okay. Show that each number is rational by writing it as a fraction. Boys and girls, this is not a fraction. It is a mixed number. So if I were to do number 23, it is negative 12 and 5/6. For some reason, your teachers taught you this thing last year where you smile at somebody, then you punch them, and then you take them to first aid. I've never heard of something like that, but I guess it works. 12 times 6. 12 times 6. That is, or that's 12. 6 times 1 is 6 plus 1. That's 72. I now take 72 and add that 5 to it. That gives me 77. It is 77 over 6. Now, this mixed number started as a negative, so the improper fraction would also be negative. So that would be negative 77/6. If I take a look, I'm going to skip 24 and go to 25. This says 4, but we have 400 thousandths. But these zeros really don't mean anything. There's no value to them, so I just write it as 4/10. But I want you guys to start simplifying fractions. 4/10, what's their greatest common factor? It is 2, so I'll divide it by 2 halves. 4 divided by 2 is 2. 10 divided by 2 is 5, so I have 2/5. Okay, you have to listen to my voice for a little bit longer. Rewrite, there's my verb, rewrite the fraction with a common denominator. Determine, there's my verb, determine whether they are equivalent, which is just a fancy word for equals. So I'm going to look at the first one, 26. We have 22 121st and 48 130 seconds. What ugly numbers. Well, first of all, I don't really want to figure out what these two, their common multiple is. Their least common multiples. That'd take me forever. So what I might do is actually, let's see if I can do this by simplifying. I think Kevin Pinsura told me about this. So I know that 11 goes into both of these. So I'm going to divide this by 11 11ths. 22 divided by 11 is 2. I think 121 divided by 11 is 11, I hope. Okay, now these, I think both of these, 12 is a common factor, I think. So we're going to divide by 12. 48 divided by 12 is 4. 132 divided by 12. Oh, I don't know that, Scott. So let's take 132 divided by 12. 12 goes into 13 once. Subtract. 1, bring down the 2. 12 goes into 12. Hey, look at that. Gives me 4 11ths. Oh my gosh, I needed a common denominator and I have it. So we have 2 11ths. And we have 4 11ths. Are those equivalent? No, they're not equivalent. You can also write this if you'd like. That's a little nicer way. Okay, I'll let you figure this one out on your own. Let's take a look at number 28 and 29, and then I will be done. So, taking a look at 71 thirds. Convert. There's my verb. Convert this to a mixed number. So I need a whole number with a fraction next to it. So 71 thirds. This also means, hey, 71 divided by 3. Numerator goes in the house, denominator stays out. I'll put a decimal. 3 goes into 7 twice. That gives me 6. Subtract. 1. Bring down a 1. 3 goes into 11 3 times. That gives me a 9, I believe. Subtract. That is 2. Okay, now, when I'm converting to a mixed number, I don't need to bring down zeros because this becomes my numerator and the divisor becomes my denominator. I just kind of fade out there. So I have 23 and 2/3. Now to check that, to make sure that equals 71 thirds, I go 23 times 3. 23 times 3 gives me 9. That gives me 69 plus the numerator 2. Hey, that gives me 71. 71 thirds. The denominator travels with me. Love it. All right, so that'd be 22 and 2/3. Next one, right, 85 fifteenths as a decimal to the nearest hundredth. So I must take this out to the hundredth place. So now I can't use that little thing right there where I'm converting it to a mixed number and using the remainder as the numerator and the divisor as the denominator. So 85 hundredths, or I'm sorry, 85 fifteenths. What am I reading here? 85 fifteenths. Okay, that means 85 divided by 15. Okay, it says to take it out to the hundredths, so that means I really should take it out to the thousands if they want me to round it to the nearest hundredth. So I should take it out to the thousands. So it says write 85 fifteenths as a decimal to the nearest hundredth. So I'll take these out to the thousands. Okay, 15 does not go into 8. 15 goes into 85. Well, 6, we learned from the previous question, is 90. That's too big, so let's go with 5. 5 times 5 is 25. 5 times 1 is 5, plus 2 gives me 75. This is 0. This is 1. Bring down a digit. 15 goes into 100. I would say 6 because that gives me 90, I believe. So there's 90. Oh, look at this. I might have another 10. Bring down is 0. Looks like I have another 100. So I see that this becomes a repeating decimal. So because of that, to take this out to the nearest hundreds, it'd be 5 and 6. Now this would be another 6. So if I take it to the thousands, okay, I am going to round to the nearest hundredth. The 6 is in the hundredths place. This 6 tells me to round up or keep it the same. That tells me to round up, so it really becomes 5 and 67 hundredths. Hope this helps you out. Take care. Bye-bye.